Good morning. This is our third lesson in solving equations for my Integrated 1 classes. Before I get started, I want to say I hope everyone's doing all right out there. Let me just make sure this tripod hasn't moved. It's getting to be a little bit having a mind of its own, and it looks like it's doing okay. Alright, so let me just quickly talk about our two goals today. Our first goal is we're going to have an introduction to solving two-step equations. We only know how to solve one-step equations, and so the natural progression is of the one-step equations that we solve, like this one we would solve by subtraction, this one we'd solve by addition, this one we'd solve by division, and this one we'd solve by multiplication. We're going to see a combination of these, and our goal is we're going to recognize which of the two we have, and we're going to work out a problem, and we're going to realize that there's a better order in solving these. So that's the point of this lesson, is we want to see that there's actually an easier order to solve equations in. So we're going to work out three problems. We're going to work them out in two different ways for each set of problems, just so we can see that there's a better order to solve equations. So that's the point here. We want to find out, of the two steps, which step is a better first step and which step is a better last step. All right. So let me grab my markers here. And I wrote the same equation twice. 3x minus 5 equals 13. I wrote it twice. And the reason why I wrote it twice is I want you guys to realize that if I cover up the minus 5, I have a solve by division problem. Okay? If I cover up the 3, I have a solve by addition problem. So this first example is actually this type of equation and this type of equation. So it's going to solve by addition and solve by division. Okay, so let's do the first problem by solving by addition first. We're going to do step 2 first, or the second type of problem first, and then we're going to do the division next. Okay, so because I have a minus 5 like a minus 4, I'm going to add 5 to both sides, right? So if I just ignore the 3, I would really have a problem like this. And so my first step would be to add 5 to both sides. And now those will cancel, and I'm left with 3x is equal to 18. And then I have now a solve by division, so we divide both sides by 3. And we see that x is equal to 6. So this is how the problem looks if I do addition before I do division. I want to do the same problem, but I want to switch the orders. I want to do this problem first by dividing, and then second by addition. All right, so when you divide, you have to divide everybody. We must divide everybody. So if I'm going to start off with division, I divide everybody by 3. And now I'm left with x equals x minus 5 over 3 equals 13 over 3. A lot of students would stop this problem right here because you now have a problem with fractions, and that tends to shut you guys down. So it seems to me that in this first example, it's better to do addition before we do division. And in fact, I'm going to run short of time today, but it would be better to do subtraction before we do division. So division is the last step that we want to do of these two. So let me write that down. So we want to do division last. Okay, so far it looks like division is a good last step. And the other reason why division is a good last step is if you do it last and it creates a fraction as an answer, That's fine. That's your answer. It's a fraction. Right, but if we do division at the beginning, we could be creating fractions. Now, we would actually get the same answer if I added 5/3 to both sides. We would see that x is equal to, well, I can add these together because they have the same denominator. X is equal to 18/3, so x would be equal to 6. But we're adding fractions to a problem. We don't want to do that if, unless you want to make it interesting, but division is a good last step. Okay, I just wanted to point that out for that problem. So I'm going to write another problem twice on the board. We're going to work it out each time, and then we will see which will be a better first step. Example 2. And I believe my problem is so I have here a solve by multiplication problem if I cover up the -2, and I have a solve by addition problem if I cover up the 3. So my two steps are going to be solve by multiplication and solve by subtraction. I just know that students don't like fractions. And so what I'm going to do is I'm going to say that you're better off on this problem if you just get rid of the fractions. And remember from the last lesson, you eliminate fractions by multiplying everybody by the denominator. And so if I multiply everybody by the denominator, you get a 3, you get a 3, and you get a 3. Everybody gets a 3, and what's nice about picking a 3 is that number, since it's the denominator, cancels out, and now I'm left with x. So -2 times 3, a negative times a positive is going to be -6, and that's going to be equal to 15. And then the next thing we do is we add 6 to both sides. Because remember, this was an addition and a multiplication problem. So x is going to be equal to 21. So this problem would be us doing the multiplication step first, and then the addition step second. Now we could also do the same problem in switching the order. And to be honest, it doesn't really matter for this problem because the steps are going to be the same. I just know from experience that if you guys see a fraction, it just really bothers you guys. It really throws you guys off. So this would be us doing addition first and then the multiplication second. So I would add 2 to both sides, and I'm left with now x over 3, because these cancel, is equal to 7. And now I do my multiplication step, multiply everybody by the denominator. You get a 3, you get a 3, and we're left with x is equal to 21. So you see we get the same answers no matter which way we do it, but I just know that you guys shut down when you see a fraction. So for me, I would say that it seems that multiplication is a good first step because it eliminates fractions. And then addition and subtraction would be a better second step, but we just saw from the previous problem that addition and subtraction are better to do before you do division because it creates a fraction. So we've actually now gotten to a point where I think we can achieve our second goal by making a rough 3-step list that we will use to solve equations here. All right, so my first our list to step, and this is going to be growing. We've only seen a couple steps so far. List of steps. So the first step I would recommend being multiplication. And the reason why multiplication is a good first step is, and this is what's going to be important, is it eliminates fractions. The second step is we're going to use addition or subtraction. And our last step is we're going to use division. We're going to use division. And the reason division is last is it creates fractions, right? So multiplication eliminates fractions, addition or subtraction isolates, and then division is going to be a good last step. So let's just look at one last problem. If I gave you something that looked like this, 5x over 2 equals 10. All right, so do I have a fraction to eliminate? Yes. And remember, I eliminate fractions by multiplying by the denominator. So what I could do is I could multiply everybody by 2, and that would cancel out, and I would be left with now 5x is equal to 20. I can't add or subtract away because that step is not in here. I don't have anything that looks like this or this. So that means I go to my last step, which would be division, and I divide both sides by 5, and I get x is equal to 4. So right now, this is our list of steps. Okay? So that's going to conclude this lesson. I hope it makes sense. Have a good day, everybody. I'll see you later.